RDC 2025, how are we feeling today? Hope you guys had a great day one and a really fun evening last night. We are so excited to be here with you today to kick off our creation track. We'll be here all afternoon sharing awesome content that we've been preparing for you all for the past year. We'll be starting it off today with how to reach every player by optimizing for all devices. But before we get started, Jan, do you think we should take a quick photo with the audience?
That's a great idea. Yeah, let's take a selfie.
Everyone smile for the photo.
Woo, RDC.
Awesome. OK, let's dive right in with a quick round of introductions.
Hi, I'm Jan Muller. I'm a senior manager on interactivity, input, and UI. And my handle is Metaverse.
I'm Jasmine. I'm a product manager on the Engine group, also known as Miss Mandy Panda. And I work with Jan in Engine on all things interactive.
And I'm John, also known as Mr. Uncloaked, and I'm a technical director in the user group.
And today, we're here to answer one of the most common questions we get from developers like yourselves. Should I really invest in making my experience work well on all devices? And how can I do that easily? Let's start with our vision. We envision a future where you build once, and your content plays well on any form factor with any input for anyone. We know this hasn't always been easy. Balancing design, fidelity, and quality across all devices can feel daunting, and it's difficult to know where to start. That's why cross-platform development has been a top priority for us this year. We want to take care of the hard stuff for you so you can focus on your creative side rather than chasing down specific technical edge cases. Just like how we provide simplicity for scaling your experience from low-end Androids to high-end hardware, we want to bring that same simplicity to cross-platform design, input, and UI.
Today, you can already create great cross-platform experiences on Roblox. We know that, the biggest games in the world on our platform. But we also know that this is hard to do. It requires a lot of specific knowledge about platforms and APIs and how they work together. Here's a typical example of Roblox code. There's nothing wrong with this. Like, you see that code internally at Roblox just as much as in external games. At the top, in the top function, we're trying to figure out what platform you're on based on capabilities. So like, touch means you're on a phone or a tablet, and gamepad means you're on a console. And then at the bottom, we're kind of like acknowledging this is dynamic, and we're trying to figure out what the user last used, this last input changed, and then show different UI elements, hotkeys, maybe change the layout based on that. Many of you might know the pitfalls from this code, especially lately as we've been adding more and more platforms to Roblox. Number one, you're making an assumption. Like, what if you're on a PC with a touch screen? Or you're on a console that doesn't have a gamepad, has a keyboard and mouse attached to it. And number two, if you write a lot of bespoke code for one device, like a keyboard, with all the different keys you have available, that is hard to translate then to a gamepad or a touch screen. The end result is something like this. It works on my machine, right? Like, it's fine on the computer you worked it and built it on, but then you put it on something like the Xbox Ally we're releasing on, and you have a PC that's mobile, with a touch screen and a gamepad, and also the users use both of them all the time. They play with a gamepad and touch the touch screen to click on a button, for example. And you see all the elements happen at the same time, touch controls plus gamepad controls, different hotkeys. It doesn't work. Or you put it on a mobile phone in portrait mode. It's very common that the layout doesn't work, all the UI collapses, nothing functions anymore the way you expect it. So today, we want to talk to you about how we want to fix this, how we're fixing this internally at Roblox, and also why it's important. John?
Thanks, Jan. There's a large business opportunity for our creators to make their experience great on every device. Yesterday, you heard about Roblox's goal to reach over 10% of the gaming market. And you also heard about our explosive growth that we've been recently experiencing on multiple platforms, including desktop, mobile, and console. Building cross-platform experiences unlocks the potential for millions of new players to enjoy your experience. You also heard yesterday from Raj about how multi-device users spend over 2.5 times more per hour and engage over 20% longer. So it's important to meet your audience on any device where they may want to enjoy your experience.
This explosion of new platforms and player trends is exciting, but it also amplifies the challenge of building experiences that work well on all of them. Our old model of targeting specific devices, like PC versus console versus mobile, like what Jan showed earlier, just doesn't meet today's demands. So instead, we're shifting toward a more powerful and scalable approach. Building to support inputs and form factors like screen size independently. Each device is really just a combination of these. My phone has a small screen with touch capabilities. My PC has a medium screen with an attached keyboard and mouse. And the new Xbox Ally has a small screen with both touch and gamepad abilities that can then dock to a large TV screen. So if you optimize your experience to handle independent inputs and form factors, it will adapt smoothly to any current or future device with any combination of these. There are 3 key principles to keep in mind when designing your experience to transform and reconfigure across these 2 dimensions. First, responsive layout, which means UI should automatically adapt to different screen sizes, orientations, and scales. Next, input abstraction, which means players should be able to interact with all gameplay mechanisms and UI on any input device. And third, ergonomic UI, which means that all interfaces should be accessible and legible everywhere. But how do you put these principles into practice? We've been hard at work this year, building the APIs and tools that make this possible. We launched our highly anticipated styling APIs, which allows you to define style sheets, tokens, and themes that can be globally and dynamically applied across your UI. Combined with our no-code style editor, this makes it easier than ever to create complex, skinnable designs.
We also released the input action system. IAS lets you take your inputs and abstract them away into actions, and it lets them group in contexts and switch between contexts, completely platform independent. Your code doesn't even have to mention any platform anymore. Later, we're going to go over the workflow of how this works.
In addition, we also released APIs to improve the handling of different form factors. For example, we introduced the preferred input API for seamless mixed input handling. Take the Xbox Ally, for example. It has a gamepad, a touch screen, and you can even connect a mouse and keyboard to it. It reports its preferred input is gamepad, making it easier for you to customize your layouts when you know that a gamepad is the expected input device. We also released the Viewport Display Size API for smart screen categorization. This API detects physically small, medium, and large screens, adding additional levels of customization in your layouts. But what does it look like to develop against all inputs and form factors? All of these APIs that we just mentioned are available now for you to explore, use, and publish in your experiences. We want you to understand which API to use as a baseline for success in each scenario, and how to go above and beyond and making your experience the best that it can be by using each API. Next, we'll dive more into each pillar and describe how to use each of these APIs by building an RPG. Now, I'll hand things over to Jasmine, who'll talk about responsive UI.
Thanks, John. OK, let's start with our first pillar, which is responsive layout. The first part of building any game UI is identifying the core elements you want from the screen. And right from the start, you should integrate responsive design principles so they are baked directly into each element, not added as an afterthought. In our RPG, one of the key UI elements we want is the item selector, which is a row of icons that holds the tools in each player's inventory that they can quickly access. We want each of these to be represented with an image of the tool inside a styled tile, like what you see on screen. Now, it's important that this entire item unit scales properly on all devices. This means that when the outer tile grows, the image inside should grow proportionally, like what you just saw. To do this, let's use scale properties to size the icon image relative to the parent frame. Here, we'll use a factor of 0.8. We'll also add a UI aspect ratio constraint to ensure that the entire item unit maintains its square proportions, no matter how it scales. And of course, the same logic applies as well when the outer tile shrinks. Now that we're happy with this individual item unit, we can duplicate it for each of the tools in our item selector. Now, since all the tools are presented together in the item selector, it's not enough that each of them scales independently. They need to work together cohesively as a group. This means they should line up neatly, have consistent padding, and maintain layout integrity, no matter how much space they have or how many items there are. To handle this, we'll use a UI list layout component, which automatically aligns and spaces the elements for us. It's one of the most versatile layout components we offer today. There are other scenarios in which a linearly horizontal layout, like what you see on screen, doesn't work. If my screen stretches or shrinks, the item selector should adjust gracefully without relying on hard-coded dimensions. This is where our new flex properties come in. We can use horizontal flex and vertical flex to ensure that items inside the item selector responsively fill and adapt to available space, all while maintaining consistent sizing and padding. Like this. This makes our layout adjustable to different screen configurations without any manual edits. The key takeaway here is that responsive design should be baked directly into each element from the start. Each piece should be designed to scale, adapt, and align, and layout containers can then help bring them all together. Awesome. Once we've built all the different individual components we want on our screen, which includes stuff like the minimap, the token counters, and the progress bars, the next big challenge is figuring out how to fit them all together cohesively on a screen. And this is where screen space and orientation start to matter a lot. Different devices have different screen shapes, as you're all aware. Some can be wide or tall, others can be large or small. And your layout should be screen aware, so elements can respond to changes in both size and orientation. Now, when we first built our HUD on our PC, the items naturally fit well together on a wide landscape screen. But you can imagine that if this horizontal space compresses, this layout can start to feel cramped, similar to that portrait screenshot Jan showed at the beginning. The item selector we already built responds well to changes in screen space and orientation using our UI list layout and flex APIs. But how can we ensure that the entire HUD, with all its elements, looks balanced and functions well across different screens? First, we should think about how to reposition and resize UI elements based on orientation. In the past, this might have meant defining entirely new UI layouts and instances. But with our new styling APIs, you can now simply swap UI tags to dynamically apply different styles across your entire UI without defining any new instances at all. In our example, we want the progress bars to move from the bottom left to the top of the screen when horizontal space becomes limited. We can do this by styling their position and anchor point properties using the style editor. And by rearranging the HUD like this, we guarantee that all players have access to the same HUD selections, no matter the orientation of their screen. In other cases, not all information needs to be visible on screen at the same time, which influences how my UI changes with screen size. Our new viewport display size API allows you to query the physical display category a player is on: small, medium, or large, like John mentioned earlier. This doesn't just impact scaling. It also influences what content you show and how you show it. In our example, we have a minimap in the top left corner that expands when clicked. When you click on it on a larger screen, it expands over the existing 3D viewport because there's enough space to accommodate it without making the details on the minimap look too small. But on a small screen with limited space, it might make more sense for our minimap to take up the entire screen like such. It's all right if the player can't see the rest of the 3D viewport or the other HUD selections when viewing the minimap. The key takeaway here is to consider how your entire UI adapts to different screen spaces. Now that we've built a UI that's configurable to different orientations, I'm going to pass it off to Jan to talk about how input fits in.
Thank you, Jasmine. Let's talk about how we want to redefine input and input abstraction at Roblox. If you remember the example from the beginning, in our RPG, we want to show different hotkeys and different hints depending on which device you're using. Gamepad versus keyboard and mouse versus touchscreen. And this is hard to do. Even experts get this wrong, like on something like the Xbox Ally. Our own UI didn't work at the beginning. In our example, so we have a touchscreen with a gamepad. And we released an API about 2 months ago that helps with this problem. It's called preferred input. Preferred input is an opinionated API. What does that mean? It means we're building in an opinion about what we think is the more important input device. So for example, here, even if the user is touching the touchscreen to click on a button, as you're using the gamepad, gamepad remains the preferred input. So in this example, we're using this API to say, oh, we have a gamepad mode, we have a mixed mode maybe, but we have a gamepad mode. Preferred input stays gamepad. We're using another one of our APIs, getImage for keycode, to show the left-right button to switch through all the tools in our toolbar. And the same API can also be used for keyboard and mouse. So keyboard and mouse in UIS in particular is 2 different devices, right? Like there's keyboard keys and strokes, and there's mouse movement and mouse clicks. And they are 2 different signals, and we're trying to figure out, like, oh, are they being used together? Do they both exist, et cetera? In preferred input, they become 1 device. Together, they're keyboard and mouse, and if a keyboard and mouse is the preferred input, you can be sure that we are only using a keyboard and mouse at the moment to play your game. And you can use that to use all the additional buttons, like here, 1 through 5, to select the different tools in the toolbar. And the same API, of course, also works for touch. More than that, we are using it ourselves internally. Like we rewrote all of our code in our own menus and our own UI to use preferred input. And when preferred input becomes touch, that means there's no other device being used. No gamepad, no keyboard and mouse. It's only touch. And that's now when we show our virtual controls. So you can use that to move out of the way, right? Like we are going to show the virtual stick and the action buttons, and you have to make space in the corners of the screen. Like in this example where preferred input is touch, and we are changing the layout, moving the toolbar into the middle of the screen. All right, cool. So we have solved that problem with having multiple inputs at once and having a touch screen and a gamepad at the same time. But our game has so many more actions going on. We built a little harvesting, planting simulator where you can dig holes. Maybe there's construction, you can build houses and walls and roofs and doors. And you have multiple arrays of tools that you want to use. Traditionally, you would have to write a bunch of code for each input method. So keyboard and mouse, call this function. Gamepad, call that function. They are not quite matching. They have different amounts of buttons. So it gets really complicated. And you have to support traditional devices as we're bringing them online in the future. For this reason, we released Input Action System. Input Action System lets you define all of these actions, all of these gameplay elements as instances in the Explorer. So you go, you create a tool context, for example, here, or next to that might be the building context, and you put all of these different semantics into the tool context. They might be toggled on and off together, right? You enable the tool group, you disable the tool group, all the actions turn off, turn on the building group. In this example, we made a dig action. We connected a little animation to it. And then we defined all the different controls, like touch, gamepad, and keyboard, as bindings. These are properties you can change. You can sync contexts. You have control over these. You can add them at runtime. You can add them through script. All of this is, of course, scriptable, as we do ourselves with player script. And it doesn't matter anymore whether you are controlling your game with a gamepad or a keyboard. In your code, it's the exact same 1 line of code. Dig action, press, connect, and you write, in this case, you play your animation or you perform your action. Your code doesn't know what hardware actually triggered the action. For all the signals, we have pressed, we have released, so you can create states as well. And the same is true for touch. Touch controls, today what we have is you can just build your own touch UI and connect them with 1 click to that action. So it doesn't matter anymore whether it's a touch screen or a gamepad. All your code references is the action itself. This doesn't only clean up your code. This is the foundation for server authority, which you might have learned about yesterday. All of these actions get replicated on the server and reproduced on the server to verify inputs and make sure they're valid for anti-cheat. Also, this will allow us to add features down the line without you having to change your code again. For example, we are currently looking into player customization, having users change their inputs on the fly while your game is running, and you will never know anything about it because it's just an action that gets reconfigured to a different key. Let's say, instead of R2, I'm using the X key to dig. All of this is coming soon, but Input Action Service is out now to try out in client beta. Next, John is going to talk about ergonomic UI.
Thanks, Jan. UI is ergonomic when it's easy and comfortable to use, with great legibility and accessibility. Users should be able to get clear information about the experience and make their inputs easily on any input device. To do this, UI should scale, wrap, or simplify itself, depending on the context of where it's used. Next, let's talk about how our APIs and style system make this really easy to achieve. First, let's talk about text. We want to make sure that text is legible anywhere. For instance, on a medium screen like a monitor, we can make text a little bit smaller and it's still easy to read. This allows you to create greater information density and take better advantage of the available screen space. However, on smaller screens like mobile devices, we want that text to be a little bit larger so that it's still comfortable to read. To do this, you can use our Text Scaled API, which will automatically scale the size of the text as its parent responsively changes its size. You can also use our UI Text Size Constraint API to configure minimum and maximum text sizes. This ensures the text doesn't get uncomfortably small or large to handle these scenarios. Here, you can see the annotation on the map where the text is larger on a small screen so that it's still easy to read, but not uncomfortably large. Second, let's talk about hit targets. We want to make sure the hit targets are easy to hit on any input device. For example, with a mouse and keyboard attached, we can make hit areas a little bit smaller, since the mouse affords the user with greater precision. But on less precise inputs, like touch, it's important to make those hit areas a little bit bigger so that they're still comfortable to tap on with your finger. To do this, you can use our UI Size Constraint API, which allows you to configure minimum and maximum sizes to handle these scenarios. For example, you can see in our HUD the items are getting larger on a small screen to make sure that it's still easy to tap with your finger. And finally, once your layout, actions, and interactions are in place, we want to make sure that the experience feels polished. That means choosing consistent colors, fonts, and shapes that reflect the theme of your experience so that it feels cohesive across all devices. To do this, you can use our style system to define themes, and these themes can be applied globally or overridden per component. This makes it easy and convenient to implement use cases such as light and dark modes, seasonal event theming, and even high contrast accessibility color packs, as we're showing here. And that wraps up our 3 pillars.
All right, we're putting it all together. We updated our game with our new APIs. We made it responsive to different viewports, to different output devices, to different input devices. You write it once, it works everywhere seamlessly, the same way with the same couple of lines of code. This is a great foundation for your games, but that doesn't mean you shouldn't use our more device-specific capabilities. So for example, gestures. We recently updated gestures to work the same way on all devices. There's the same implementation for swipe and drag, no matter whether you have a touch screen on your laptop or a tablet or a little trackpad. Or haptics. We updated haptics to be effect-based, which means that you create an effect, you give it a position, and we figure out, based on what hardware is being used, is it 1 motor, 2 motors, is it stereo, does it have 4 motors? We're figuring out what should play on that device. Or VR, where like you have room scale tracking and you have arm tracking. Use those APIs to make your game feel special for that platform. Also, don't forget Studio Emulation. Almost all of our APIs can be tested in Studio, including VR, including the Xbox Ally, before you have to hit production and find bugs there.
We know that building for specific inputs and form factors independently is a shift from what you're all used to. But it's a shift that sets us up for the future, one where your experiences are more adaptable, more inclusive, and ready for the next generation of devices and players. If we can leave you with 3 key takeaways, they are the following. First, design responsive UI elements and layouts that automatically adapt to different screen sizes, orientations, and peripheral configurations. Make sure individual elements dynamically inform parent containers and vice versa, and use our UI primitives, layout components, and new APIs like Flex and Viewport display size to do so. Next, enable player interaction across all input types, from touch to gamepads and controllers to keyboard and mouse. Use our new input action system to define data-driven actions and our new preferred input API to translate connected inputs to UI changes. And finally, prioritize ergonomics across all combinations of inputs and form factors at scale. Define size constraints for both text and elements to ensure legibility and accessibility, and use our new styling system to dynamically swap out visual sizes, layouts, and themes. As you start applying these principles into your projects, we'll continue building toward a future where cross-platform compatibility becomes the baseline for all experiences. Our vision of build once, play everywhere will become even more powerful and easier to achieve. So stay tuned.
So thank you all for coming to our talk today, and we hope to see you soon on the show floor. We invite you to our device lab, where you can get more hands-on with a range of different physical devices. Also, feel free to join us in the creation support area, where you can get more support on how to use these APIs. And also, you can scan this QR code to download the experience we've been discussing throughout this talk, see how things are working more concretely, and check out all of our other documentation resources. So once again, thanks, and now we're going to open things up for Q&A.
I think we have mics on both the right and left of the stage. You over here.
Hello.
First.
My name is Busy City Guy. I joined in 2012. And this question was about Jan's slide. You mentioned that preferred input does not change, even if they change what input they're using. Typically, I'll listen to last input changed so that I can show like touch controls if they start using the touchscreen, for example.
Yep.
What is the recommendation here? Should we care about last input type changed, or should we always use preferred input for showing context hints and intaking controls?
Yeah, thanks for the question. That's actually good to clarify. So preferred input does change. It has timeouts. So for example, if you swap between a gamepad and a keyboard, it will change basically instantaneously. If you swap between, like you have a gamepad and it's attached and you have used it, but now you're just using the touch screen, it will not change instantaneously. It has a timeout, after which it will change back to touch only. And we're still tweaking this too. Like this is still a new API. We're still figuring it out ourselves. The recommendation is to use preferred input over last input unless you really want to know for some reason that there was a mouse click or that there was a specific keyboard stroke. Preferred input is more stable. And like the problem that I was seeing with last input and we were seeing internally is that it's just very easy to make mistakes where, for example, React code would re-render every time a stroke happened. That gets expensive for no reason, right? Preferred input is stable and doesn't do that.
Thank you.
Other questions?
I think we have another question over here.
Hello. I
Hi.
have a quick question about input bindings and movement 2D. There's good support for keyboard and good support for gamepad for movement 2D. There's not really for touch. I wondered if there was any plan to use the virtual thumbstick or even the accelerometer or gyroscope.
Yes, to all of them. So full transparency, we wanted to get IIS out for a long time. We've been working on it. We have been working on server authority. We needed it for that. So we have been shipping in August, knowing that touch isn't fully done yet. We're shipping all of the APIs you just mentioned in IIS. Everything that CS and UIS supports will work in IIS as well. And as we're doing this, we're actually translating our player script, our own defaults, over to IIS. So everything that's in there, including the virtual sticks, have to work in IIS going forward.
Awesome. Thank you.
Yeah.
Next question.
Hi, guys. Boat Bomber, 13 years on Roblox. First of all, I just want to say thank you for your work. This has been a big pain point for many years, a lot of reinventing the wheel. So really appreciate the platform supporting that natively. I was curious, I saw that the API has pressed and released for these actions. And a common pattern is to use activated, which has, it needs to be pressed and released both on the same button, whereas pressed is only on the initial tap and releases. Does the released API only fire if the touch input started and released on that button, or are developers going to have to re-implement the activated behavior manually?
I want to say only when it's on that button. I'm like 99% sure.
I'll take that.
Yeah. We also like talking about stuff like debounds. We saw that on the forum that people want to have debounds. We're working on that as well. So it's still in production.
Awesome. Thank you.
Hello, this is Kyle's 4 through 8. I think you already talked a little bit about it, but you mentioned the new input bindings API has a little bit of server authority, like security measures put in place. I was kind of questioning what some of those may be, because one common thing that I end up doing a lot is adding like a leaky bucket algorithm to like prevent input spamming. So like if an exploiter or a bad actor wants to spam an input, it will catch that if they're doing it too excessively, but also like making sure someone with like high latency isn't getting false flagged for that.
Right.
But are there any like other security measures in place for that, I guess?
So to clarify a little bit, so server authority is like our comprehensive system of running the game logic on the server, having distributed script that runs the game logic both on the server and the client to validate what happened on the client is actually doable on the server. IIS is the foundation for that, meaning the state of IIS, the state of a binding, the button being pressed, how long it was pressed, is being replicated to the server and re-simulated there, right?
Okay.
So that's the foundation. The other part of the question of like whether we have like a check, like whether it was humanly possible to click that fast, there's another feature we're working on that we kind of announced called fixed update that will do some of that, where we have a fixed update input and we have some control over how quickly buttons can go up and down. So stay tuned.
Awesome, thanks.
Hello, I'm Ember API. I saw you guys mention that we should use text scaled for some design. So from a design standpoint, would you prefer that we use text scaled versus automatic sizing and wrapping when things get localized and strings get longer, that sort of thing?
Yeah, great question. So text scaled is pretty specific to text, and automatic size can be applied to all of your elements. The way we think about automatic size is you want any children to dynamically inform their parent, and so automatic size will do that for text, for children elements, like additional frames, text labels, image labels, et cetera. We would recommend using, if you need to use both, you can totally use both. And for automatic size, we know that there are a lot of different combinatorics of how developers use automatic size that may lead to unideal results, and so those are a lot of the bugs that we're working through right now on our UI team. But specifically for text, we do recommend you keep using text scaled, and we'll take care of how that works with automatic size for you.
Cool, thank you.
Yeah, of course.
We have time for maybe one more question. Anybody wants to go? Or not?
Awesome. Thank you guys so much once again, and please come visit us at the Creation Support area or the Device Lab if you guys have any other questions. Thank you.